Is that okay? Current sustainable upcoming filter media. Guess what is the current media that is really important for us? Huh? Current one. Hey, I told you last time. EPTF is certainly. Huh?
Is it sustainable for environmentally?
Yeah, I can tell you one thing. Currently, the PTFE or PVDFE, the membrane-wise PVDFE, the solution casting method of producing, that's a really popular one. So still it's everlasting material because it relates to the fluorine there. However, I don't know whether I mentioned about it or not. Enzyme development is quite currently active. For instance, the polyethylene-wise, the enzyme is already, I don't know, it's still under the development. But once you come up with the enzyme for certain polymeric material, then degradation is no issue at all. So I strongly believe that within 10 years, they can come up with some enzyme or put some branching into the PTFE molecules so that it can be biodegradable. So yeah, currently it's not. But to me, within 10 years, they can come up with some solutions for that. So I strongly believe the EPTFA is future direction. Yeah. Because pore size is small. Also, he actually mentioned really good question. Uniformity. EPTFA, you don't have to worry about it. You always come up with the same one. But solvent casting, that sort of thing, no, there is no way you can repeat over the time. And then uniformity across the web, that is key issue. So the solution is we can have biopolyethylene, biopolypropylene, biopolyester. However, once you polymerize it, then it's the same issue. Even though it has a bio in it, but it's not going to be biodegradable. So monomer comes from a little bit, the natural source. But the other one is petroleum-related source. That's the only difference. Once you polymerize it, it's going to be the same. However, there is some issue. Carbon footprint. Carbon footprint is starting the material to end the disposable. So, first part of it is related to sustainable material because starting with biodegradable material, right? But once you make the polymeric material, then it's the same as petroleum. But half of the size is the carbon footprint wise almost zero. So carbon footprint is concerned is a lot less. That's why people are quite they are interested in looking into in the biopolymers. So developing sustainable liquid filter media, first of all, eco-friendly material, they can filter liquid while reducing environmental impact. This field involves environmental engineering, material science, industrial process, tailoring, medical food, municipal water treatment. This is quite important one. This one actually I made it. I made this chart. Sustainable filter material, two categories. One is synthetic, the other one is natural. Synthetic material, biodegradable material, the PLA certainly is biodegradable. PHA, PVA, PCl, PVS, all of them are biodegradable synthetic material. Down here is a long-term degradable P, PP, PET, bio-PE, bio-PP, bio-PET. But I didn't put EPTFE, PTFE there. Currently, is everlasting material. I didn't put it at this moment. I can put it sometime later. What about natural material? So all of them, the cotton, jute, coir. You know what the coir is? The pineapple, not pineapple, huh? Coconut. Yeah, coconut. Yeah, hemp, rami, bamboo, lignin, viscose, canal, silk, wool, nanocellulose, metal, nanoparticles. So currently, in US, the same thing. My wife told me that you have really nice bedspread, so made out of bamboo. So the feels really great, but there is the issue. The durability is not there. It doesn't go last. I normally when I sleep, probably my leg wants to move really a lot. That's my wife always complain about it. That's why one place we can easily make hole. But synthetic material, it never happened. Made out of bamboo is that is easier. Also, the cost is higher too. So synthetic material durability is key issue to me. But feeling is great because it's the natural material. So to me this is this is one of the solutions. Hybrid between natural material with a synthetic material. So this slide to me is quite important one. No one has it. I need to patent it. I don't know whether I don't think so, but the natural material, mechanical durability, natural fiber, great. Wet condition and pressure, so degrade really fast. That is the issue. The standardization is tough. So normally the natural materials, the quality-wise, so vary. Whether it comes from Asian country or whether it comes from some other countries or something like that. So it's not the same quality, a lot different. So cost and scalability. Scalability is quite an important part of it. So large scale production and processing can be costly. Here, this is current filter media. That's what I like to talk about it. Huh? So once you read it, probably you may guess what material that is. So due to excellent chemical resistance, high filtration efficiency, maintaining low resistance, not zero resistance, because of its high surface electric charging characteristic. So polyethylene, polypropylene nanomaterial becomes standard material for filtration applications in air and liquid filtration. So polypropylene and polyethylene, how long it's gonna be survive? I believe, to me, at least 20 years or more. You know why? First of all, it's easy to process, making fine fibers. The other important thing is polyolefin. You can easily electrocharging. Charging is easier, a lot easier. So the current filter material, available in the marketplace. To me, the polypropylene is number one, polyethylene is number two. Slowly, EPTFE is replacing by some material replacing by the EPTFE, but cost is too high. That's why it's not going to be that fast. Now, however, polyethylene and polypropylene, I believe it will stay more than 20 years from now. Here in US, I don't know about in India, every household or building, they have to use filter. Filter in every house. In my house, I have to change the filter every 3 months. Change it. Air filter. Air filter. Well, liquid filter as well. They actually use membrane. No, not membrane. Melt blown. A lot of those. Yes, melt blown. Water filtration. He showed you some sort of cartridge, round cartridge. A lot of those is polypropylene membrane, not melt blown material. Yeah. Also, 99% of face mask out of the melt blown material. Water filtration is polypropylene, the melt blown material. So the key issue is it's easy to charge the surface of it. Then what happened to the liquid side? Still its effect is charged not charged. So, not as great as the air, but liquid is the same thing though. But there are some biopolyethylene. I'm going to talk about this biopolyethylene terephthalate made from renewable raw material in the marketplace. However, these polymer are not always biodegradable, even though they are recyclable. That is a little bit of the issue. Then, how biopolyethylene, polypropylene, or biopolyethylene terephthalate can be made? So bio-based plastic man-made, man-processed organic molecule derived from biological resources for plastic and fiber application. What is public concerns? Environment, waste, pollution, and climate change, carbon footprint. Carbon footprint is a big issue. Bio-based plastic could reduce environmental impact and carbon. That is true. Carbon footprint-wise, plastic material helps a lot. Also, they are all recyclable. This is how the biopolymer made. The starting raw material is the sugar cane or sugar beet, garlic skin, cereal corn, agave. You know what agave? Agave is the raw material of tequila. Mexican tequila is made out of agave. And the wheat, that is what? The whiskey. Why I didn't put corn in it? Yeah? Oh, corn is there?
Seedlings. Besides seedling. Garlic skin and corn.
Yeah. The corn should be there. And because I came from Kentucky, Bourbon County, home of bourbon. So material. This is raw material. Then fermentation. Fermentation is quite important, and glucose end up with ethanol. Some of them are edible, but this one, it doesn't have to be edible ethanol. Even though it has a lot of the impurity in it, it still is okay. And then,
Ligno-cellulosic.
Ligno. Oh, the cellulose has a lot of different structures. Lignocellulose has a little bit. You need to look at the lignocellulose is a kind of cellulose, but it's a long chain. The chain is a little bit longer. So here, whiskey from Bali, bourbon from Icon, tequila from agave. For your reference. And then dehydration, then you can make bioplastic. This is the one of the example. Brazilian Braskem petrochemical company. Actually, the Braskem is associated with Dow Chemical. So currently, they produce the bio-PE. The raw material is the sugar cane. But the price is not really high, but it's 1.5, so it's a little bit higher than polyethylene currently available in the marketplace. So this is bio-PE, but there are bio-PP, bio-PET is available. However, the process stays the same. So how to make the biodegradable plastics? Currently, most of the effective way make the biodegradable polymer seems to be biodegradable additives such as vinyl vinyl acetate, starch, pro-oxidant like iron, manganese, and cobalt, or UV stabilizer. This is the issue. See, most of the plastic material, the polyethylene, polypropylene, they do use a lot of UV stabilizer. UV stabilizer, yes, UV. So the one conference I actually suggest to reduce the UV stabilizer so that it can biodegradable quicker. But I doubt it. I doubt it. So if they reduce the UV stabilizer, sometimes UV stabilizer give you some the oxidation better. So anyway, this is the big issue currently. So all the big company, Exxon and Dow, they can reduce the UV stabilizer. Then normally polyethylene, polypropylene, it degrades a lot quicker. So to me, this is what I'm thinking of, not from somebody else. This is my kind of thought. Yeah. Appropriate enzyme development specific. I believe this is key to me. Key. The last one is not easy one, chemistry portion of it. So even PTFA, they can put biodegradable branch a little bit there, and then it can be biodegradable later on. So currently, the biodegradable testing, yeah, a lot of them. ASTM is key. ISO has some. But actually, when I read about it, it's not really biodegradation of plastic material. So it's kind of the short-term the testing. Somehow there are a lot of the missing portion of it, so they have to upgrade. Okay, this is the issue. PFAS, here, polyfluoroalkyl substances, they call it PFAS. The last time when I was here, the person asked about the PFAS. So PTFE or PVDFA is under the PFAS. So somehow in Europe and Asia, there is some restriction on the PTFE and PVDF as well. The issue is this one. PTFA, there is no way it dissolves in the water. So it's really safe. But bad portion is still under PFAS. Now I'm gonna talk about something about the nano size, and then currently available the filter material. Show you. Certainly nano size, we already talked this one last time. So synthetic pressure drop wise is a lot lower compared with the glass. The synthetic media production, biaxial stretching, melt blowing, spun bonding. We already talked about that one. Penta is there. Also, I already show you this one as well. The melt blown. I also have the melt blown machine pattern, about 3 of them. So it really depending on the design. Then you can actually go down to 0.5 micron size melt blown. Normally, melt blown material, the fiber size has big distribution in it. So if the fiber size is, all of them are smaller, then pressure drop gonna fit. So combination of the fiber size, that's why pressure drop is lower. So it's polypropylene, certainly in water filtration area, they do use a lot. This one is a popular one. Yeah. So some of the fibers are really fine. Here, that is liquid filter made out of the Macron. But air, they use a lot. How long? I strongly believe in probably more than 20 years, I believe. Because there is no way they can replace this material. The price-wise, also the performance-wise. But this is the one of the big company in U.S. They are making money out of this product since 30 years ago. They are making the HVAC material called Interpret. So this is the spun bond material, but polyethylene and polypropylene combination of it. They also charge it. Also, there is some so-called triboelectricity effect too. What is triboelectric? Triboelectric is if you have two different fiber material, then rubbing each other, then it creates charge. So even though it has the surface electrostatic charge in it, along with during the process, it creates triboelectric charge as well. That's why this product has been popular. Also, it's spun bond, so the production rate is really high. So cost is a lot lower. There is no way somebody else compete with this product as far as cost is concerned. So this company is making bunch of money out of this process. The HVAC market is not really high efficient. It's kind of intermediate area. Also, liquid filter not really high area like melt blown, but this is a lot lower than melt blown. But they do use this one. material. Well, this is the air filter, but all of them made out of polypropylene. So electrostatically charged, expanded polyethylene terephthalate currently for front of air filtration as well as liquid as well. Here, charged PP, charged PE, brand, EPTFE, the efficiency, delta P, fiber size, melting point. Yeah, look at this, melting point. EPTFE, 327 degrees. Actually, you can go up, it can go up to 304 operating temperature as well. Because the PTFE has really sharp melting point. That's why operating temperature, you can go up to 300. And next one is the charged PP and charged PE, P brand, and EPTFE. It's kind of similar, but when you look at the EPTFE membrane, 99.9 plus. So I strongly believe the next 10 years you will see a lot of EPTFE in liquid filter area. Durability was really great. Here, the electrospun material, the key issue is strength. So, electrospun material, you can use it in the air, but if you want to use in the liquid, then it has to bond with a certain material, really highly bonded certain material. You know why? Strength of individual fiber is really low. So once you rub it, it just becomes powder. Even you are rubbing slightly like this. That's why the electrospun fiber is tough to use in the liquid area. Yeah, I believe that they can use. So, current and upcoming air filter media. Number one. This is not mine. So you can actually look at it, the internet, and ask AI. That's the one. Then certainly come up with a number on it is different. Efficiency-wise, pressure drop-wise, durability, and cost is the issue. It's a little bit high. Not a little bit. Sometimes it's really high. But efficiency is way up. Huh? What about stretch for the olefin? Efficiency is relatively good. Pressure drop, I told you earlier, since porosity is a lot lower than that of the EPTFE, so the pressure drop is low to moderate. Durability, yeah, normally is good. The cost is, I think it says high, but I don't mind, it's okay. And what about this one? Good ready. All of them we use in the liquid area too. The current and upcoming liquid filter media. number one is definitely rank right there. Ceramic membrane, the number two. PVDF is number three. Here, look at this. PTFE, PVDF, they are on the P5, but still it's number three, number one. Ion exchange media is number five. Stretch polyolefin is number six. So, the expanded polyethylene strength is exceptionally chemical resistance, hydrophobic, high thermal stability, very fine pore structure, low pressure drop. It has everything, good one. See, application, critical pressure, pharma, bio, they already use it. Even in the HVAC market, slowly the EPTF is replacing with some other polymeric material or glass material. So cutting edge use often use the high-end filtration, ultra pure liquid and gas. Yeah. Ceramic membrane is getting popular, strength extremely durable, chemically, thermally resistant, long lifespan, backwashable, and highly fouling resistance. That is true. See, ceramic material, you can burn it and then reuse it. See, application, wastewater treatment, food, beverage, pharmaceutical, high temperature, cutting edge use, becoming increasing commonly in advanced water recovery or harsh chemical process. PVDF, this is quite the important one, even though it's a solution casting material, however, but it's quite popular material because of the strength, chemical resistance, good thermal property, excellent mechanical strength, application, ultrafiltration, microfiltration filter, pharma, and water treatment. Commonly membrane bioreactor, MBR, we talk about it, right? It uses the PVDF membrane. Later on, probably they might replace with expanded polyethylene, the EPTF. I strongly believe that's going to happen really quickly. The PES, ether sulfur, this is high temperature polymer they call it, but not compared with the PTF. Yeah, good mechanical strength and the application in pharmaceutical, medical, and lab scale sterile filtration. Sterile filtration ultra, though less chemically robust rather than compared with the PVDF. As far as the membrane, so-called nominal membrane is concerned, PVDF is number one currently. The ion exchange media, there are some available, very expensive. So, crucially in ultra pure water system, they do use some ion exchange media, though not the physical filter, the ion exchange. What about the stretch polyolefin? So it's inexpensive, chemical resistant, but application pre-filtration because the efficiency is not as good as the EPTF. use cost and reversed matter more than precision or fine filtration. So, core of modern liquid filtration media are polytetrafluoride. This is a bit different one. It's not EPTFA. Even though PTF itself, you can make the solution casting or different process to make the. It's nothing to do with the EPTFA. Nylon PTFA and then polyether sulfone is good one. So ceramic membrane and synthetic depth media made out of polypropylene and polymer or activated carbon media. This is really good. Activated carbon media removing chlorine, organic compound, and odor. See, in air filtration, the removing odor, we use a lot of activated carbon. This is common material. The sintered matter is, you can use it, but efficiency is low. But I believe some of the applications they do use sintered matter, ion exchange, and biodegradable cellulose compound, tryptophan-based media. So, emerging for eco-friendly application, single-use system. Challenges and opportunity. What about the silk cellulose-based filtration material? Silk is quite the attractive material, but if you look at the fiber size, is that really fine? Consider it as a fine material? Fine? I doubt it. When you compare with the EPTFA, the size-wise, the 2 nanometer, 2 micrometer, less than that. So silk is rather big compared with that. However, PFAS, removal PFAS, this is solution state. They can actually remove it. Biochar-based media, carbon-rich the byproduct. Biochar is quite popular currently. In the liquid area, waste, especially the wastewater treatment. Graphene oxide it enhanced the filter. This one still under development somehow. The bottom here, smart filter. This is the quite getting popular. Sensor, now the sensor, the cost is getting lower and lower. So you can put the sensor. I don't know whether you notice or not. Some of the shot has a sensor in it. So once the heartbeat is to a certain level, it actually changes the color. It changes the color. So it actually warns you. Don't run that fast. You're gonna get stroke something. So currently the sensor cost is quite low. So everywhere they like to use sensors. sensors around. But they call it smart filter. Using that. I believe every field they have to look at the sensor. This is the future direction. So the living filtration membrane, self-healing water filtration technology. Also, 3D printing is getting popular. 3D printing is getting. Do you have it? 3D printing. Yeah.
Not in the department, in other department.
Yeah, this is getting popular. So, the company that I used to consult with now all the frame filter frame is using 3D printer making. Yeah, this is quite. Also, natural ceramic membrane derived from the clay and zeolite. Recyclably used. I believe this is my last slide. So, huh? Any questions? In fact, this is my area of expertise on it. Which means I can do better than anyone else. Okay. If that is not.
I have one question. You talk about the biochar, no? Biochar. You are getting it from coir and other natural fibers. Biochar.
Biochar raw material normally comes from China.
Okay. Yeah. But the main source is cellulosic material and all.
Correct.
After pyrolysis and all.
Yeah.
Now, how are you going to do that?
You have to burn it. No, you have to burn it. Raw material.
What I'm saying, you are using it, no? You are using it as a filter media. How are you going to use it? As a granular form or as some kind of activated carbon? Yeah, kind of. Activated carbon.
Yeah.
Biochar is, whenever it is produced without the presence of oxygen. Yeah. Okay, at high heat. Yeah. And in India also a lot of biochars are available. Like activated carbon, you can
Yes.
that way.
Yeah. It's more like the activated carbon. Similar to it. Biochar.
It operates for absorption purpose. Okay, gaseous absorption. In the poly, if you see that cartridge I had shown you, the outside there is a layer of filtering. Inside the activated carbon is there. So you are not getting smell from the water. Okay, it absorbs some of the organic compound. Is it as a granular form? Granular form.
It is granular. Correct.
If you are using it in the mass, okay, so granular form is used. He is also working in the area with Ajay. And also it can be used in final form. There are pros and cons in both the cases. If it is a granular form, uniformity will be less. Okay, whenever you putting it. If it is in a powder form, uniformity will be more. So you can, it could be in a powder form, it could be in a granular form. So when you are using it, you are using it as inside an encasement or as a multiple ways. For example, in cartridge, water resistant cartridge, that is a thick layer in the pipe. Okay, just after the outer fabric, inside you can have a thick layer of column form. So that is in the granular form you can use. But if it is a for face mask, if it is a for respiratory purpose, okay, so one can have a lot of that activated carbon inside one particular chamber. Okay, but if it is a simple respirator for industrial purpose, for example, gaseous environment, someone is working. So in that case also one can have. layer of that material. Okay, whenever they are
Okay.
making the
Yeah.
two kinds of respirator is there, externally supplied, and also you can take it the air